So now how do we how do we describe the gradient of a displacement time graph? So how do we describe the motion of the object using the displacement time graph? So when you look at this coordinate here, again, it's very nicely fitted out for you, right? For the purpose of discussion and because we're just beginners. So if you look at time equals 1, right? At time equals 1, displacement equals 2 meters. And at time equals 2, displacement equals 4 meters, right? So when, look here, when time increases by 1 second, your displacement increases by 2 meters. So when time increases by 1 second, displacement of the object increases by 2 meters. Alright. But look at the graph. We're dealing with a straight line graph. Okay, we are dealing with a straight line graph. Alright. So what we have here is a straight line graph. Which means the gradient is constant at all points along the graph. The gradient is constant at all points along the graph. Right? And I can quickly show you what I mean by the gradient is constant. Okay? We learned that gradient equals rise over run. So let's choose this 3 and 5. Okay? Here we have the run, which is 5 minus 3 equals 2 seconds. Here we have the rise. So when time increased from 3 to 5 seconds, the displacement increased from 6 to 10 meters. So the rise will give us 10 minus 6 equals 4 meters. So rise over run will give us 4 over 2 equals 2 meter per second. And is it constant throughout? Yes, because it's a straight line graph, it will be constant throughout. Because if I choose this coordinate and this one, this will be the run, which is 10 minus 6 equals 4 seconds. And this is the rise, which is, so when time increases from 6 to 10 seconds, the displacement increased from 12 to 20 meters. So 20 minus 12 gives me 8 meters. So the gradient equals rise over run, which is 8 over 2 equals, 8 over 4 equals 2 meters per second. Now, to give a comprehensive description of the displacement time graph, we now say that, the displacement of the object increases, right? We say increases because every time it increases by 1 second, the displacement increases along the graph, right? So increases at a constant rate. Now we say it's a constant because the gradient is constant. It's a straight line graph. So we say it increases at a constant rate of 2 meters per second. Sorry. At a constant rate, increases at a constant rate of 2 meters. The displacement increases 2 meters. So displacement of the object increases at a constant rate of 2 meters for every 1 second. So that is a more comprehensive description of an object using the displacement time graph.